So far we've said that a function is a rule which provides exactly one output to each input. And now as true as that is, I think it'll be helpful now for us to talk in a little more detail what a function really is. So function, we're going to say, has these three parts that help clarify what it is. So function, first of all, has a set of inputs, which is called the domain, has a set of outputs, which is called the range, and is a rule that provides exactly one output for each input. So there's that same language from earlier, exactly one output to each input or for each input. The third part can also be said a slightly different way. You can say, is a rule that provides, comma, for each input, comma, exactly one output. You'll notice still the phrase exactly one output. Those three words are still right next to each other. By the way, language such as exactly one output for exactly one input is not acceptable. This is people trying to have it both ways. It's got to be that each input leads to one output, or to exactly one output. So earlier we looked at the following. We looked at this. We said, consider the function f of x equals 8 over x minus 3. Is there any input x for which f of x would not be defined? And without going through all the steps again, we had determined that f of x is undefined when x equals 3. So in other words, all numbers except x equals 3 work as input. So the domain is, recalling what the domain was, right? It's up at the top. A function has a set of inputs called the domain. So this domain, in other words, the set of inputs, is all reals except 3. We just talked about how all inputs work except 3. More typically, the domain is going to be written in interval notation. So we haven't gone through this interval notation in complete detail, but I want you to just kind of look at it by example for now, and we will clarify this a little later. Right, so the domain of this function is all reals except 3, and here's a way to write this. So this first part gets all numbers smaller than 3. The next part gets all real numbers bigger than 3. And so this is just our way of picking up all real numbers with the exception of the number 3 itself. OK, just clarification, the domain is a set of all real numbers which can be used as input that produce a real number as output. Sometimes people try to say the following. When asked, what's the domain, people say x, or the x, or input. That's too short. It's too cheap. It does not describe, unfortunately, it does not describe what's really going on with domain. So instead, I mean, maybe the clarification at the top is rather long, and I get that. But at a minimum, to think about what domain is, you need a phrase, something that goes something like this. The set of all x, all possible x's, all possible inputs. It's important to get at this idea of set, that there's many of them. And so collectively, all the inputs together, that's the domain. Okay, so better is the set of all real numbers which can be used as input, something like that. Okay, so how do we find the domain of functions? Keeping in mind that the domain is a set of all real numbers which can be used as input, so that we get a number, so that we get a real number as output. Well, by default, so to find domain, by default, the domain of a function is all real numbers unless something creates an exception. So for example, the domain of f of x equals x cubed plus 3x plus 6 to the x is all reals, which is written parenthesis, negative infinity, comma infinity parenthesis. Now here's an exception. If you have a function written with fractions, that's a place you've got to be careful. That's going to create an exception, because when you have a fraction, you might accidentally have dividing by 0, right? So when the denominator is 0, a function is undefined. So we need to avoid the denominator being 0 when finding domain. So for example, the domain of f of x equals 1 over x minus 6 is all reals except 6. So just so you know, there are other ways to create exceptions, and we are not going to talk about them at length right now. But just to preview, we will later see that functions that are written with square root signs and functions that are written with logarithms can also create exceptions to having all reals as the domain. For now, we're going to focus on fractions as being the only exception. So let's find the domain of f of x equals x plus 3 over x minus 6. So which values of x work, right? That's what domain's trying to ask. What values of x work? Well, we're going to talk about what values of x don't work, right? So we can't have the denominator being 0. We can't have x minus 6 equals 0, and so we need to avoid x minus 6 equaling 0. So if we add 6 to both sides, we're trying to avoid x equals 6. That's really it. It's the only value of x that causes a problem. All other values of x work just fine. So the domain is all reals except 6, and the usual way to write this is parenthesis, negative infinity, comma 6, parenthesis, union, parenthesis, 6, comma infinity, parenthesis. The numerator being 0 isn't going to cause any problem. It's OK to have 0 in the numerator of a fraction. let's find the domain of this other function, g of x equals x plus 7 over x squared minus 13x plus 30. So we need to avoid the denominator being 0. This creates an equation, and we can factor and end up solving the, after zero product property, we'll get x equals 3 or x equals 10. So we need to avoid the situation when x equals 3 or when x equals 10. So if we take all reals except 3 and 10, then this is what this domain will look like in interval notation.